Okay, so we're going to revise Venn diagrams in this video. So please make sure you've got a piece of paper and a pencil so that you can do some of the questions before we do. And please remember to pause the video to read the question and try it if you're going to do it before I do it on the screen. So we're going to start here with question 3. This Venn diagram question is based around actual students, and the fact that they tell us here that there's 80 students in the year group tells me that when I finish there needs to be 80 students inside that rectangle. It's called the universal set. So reading through my information, I may not start to put it in the diagram straight away. 9 students study French and German. So this is going to tell me that 9 students need to go into the diagram for French and German. French and German is this overlap set here. So in that overlap set, I know I need to put my 9 students to do French and German. 35 students only study French. The fact that it says only study French means that there's 35 students in the section where there's only French being taught. That's this bit over here. The 9 students do French and German, so there would be 44 students altogether, but 35 of those students only do French, so 35 in that section there. 2 students do not study French or German, so these 2 students that don't study French or German would be outside in this outside space. Anywhere in the outside space as long as they're not in the circles. So 2 students that do not study French or German. We're told that there's a total of 80 altogether, and I'm missing a number for this section here. When you finish a Venn diagram, there needs to be a number in each section. If there's no number, the examiner will assume you meant 0. So if I put together the 35, the 9 and the 2, I got 46 so far, and if we need to get up to 80 students, that must mean there's 34 students who study only German. Work out how many students study only German. 34. Question 4, this one's already been filled in, but we need to answer the questions underneath. So at a wedding, the guests may have ice cream or custard with their dessert. The Venn diagram shows the choices the guests made. So as you can see, as there's a number in every section of the Venn diagram, there is no calculations for us to do to fill in the picture. Quite often they put a few in and ask you to fill a few in, but in this one we don't need to do it. How many guests had custard? So these are the guests who chose custard. It's not just the 34. The 9 people chose ice cream and custard, but if we were asked about the custard choosers, those 9 would need to be included. So we have 43 guests who chose custard. How many guests had ice cream and custard? These are the people who had both. So how many guests had ice cream and custard? That's going to be just 9. How many guests went to the wedding? Everybody is represented. So to know how many guests went to the wedding, we have to put the 51, the 34, the 13 and the 9 together. And there's 107 people altogether at the wedding. So this one now, we've got the rectangle and we've got to fill in the Venn diagram ourselves. And then underneath we've got 3 parts of a question that we need to answer. First of all, you've got to decide how many circles you're putting in the Venn diagram. And as this information here is telling me about 2 fitness classes, I need to make sure that I've got 2 circles. They don't need to be perfect circles, but what you do need to make sure is that you've got enough overlap here so that you can put a number in when you need to in a moment. So on Saturday, 100 people visited the gym. This tells me that altogether in here I'm going to have 100 people, but it's not going to be simply splitting it as I want. I've got to make sure I've read all the information. 18 people did the spin class. Well, I haven't labelled them up here, but I'm going to make this one spinning and this one circles. So that 18 people would be in that entire circle. Obviously, I can't tell 18 how many are in this bit and how many are in that bit. I'm going to have to carry on reading, but that entire circle will be worth 18 when I've finished. Then underneath I'm told 10 people attend both classes. Well, I can do something with that, because if 10 people attend both classes, I know that there must be a 10 in the overlap section. Now when I think about those 18 people who did spin class, I actually know 10 people did both classes, 8 people did just spin. The 56 people that did not attend either class, they would be outside. They'd still be in the gym, but they're not in the gym doing spin or circuits. So as there's got to be 100 in the entire picture, and I now know that I've got 56, 10 and 8. And there are 74 people accounted for. From the original 100, this tells me that there must be 26 people who did just the circuits lesson. So in the bit underneath I have, find the probability that a person attended only circuits. So as is a probability, it's going to be out of the 100 people who are in the gym. Only circuits was that 26 people I just worked out. Part C, exactly one class. Well, this time they're not bothered about whether it's circuits or cycling. So this time it could be the 26 people or the 8 people. I put them together and say there's 34 people you could choose that have only done exactly one class out of the 100 people at the gym. And part D, attended spinning, given that they attended circuits. Well, if I know that they went to circuits, they must be out of this circle here, which there's only 36 people. So it's out of the 36 people who I know went to the circuits class. And if they attended spin, they must actually be the 10 people here. So that would be 10 out of the 36 people that went to the circuits class. Question 7. Jennifer asked 80 people which sports they enjoyed from football, hockey and rugby. So we've got 3 circles. The fact that she asked 80 people means that every section in there would add up to a total of 80. Part A, how many people enjoyed all 3 sports? That would be the 31 people here that are in the overlap of all 3 circles. Part B, how many people enjoy football and hockey but not rugby? So here are the people who enjoy football, here are the people who enjoy hockey, but as we said that they did not enjoy rugby, we would not include anybody that had been in the rugby circle. So you can see that we've now got this 14 people here who enjoyed football and hockey but not rugby. Part C, how many people enjoy football and rugby but not hockey? So football, rugby, but not hockey. And you can see that for that section, we're going to have the 17 people that are in the football and rugby but not hockey section. Work out which sport is enjoyed by the most number of people for part D. Well, the football circle, this circle here, has 31, 14, 17 and 4 people in it. The hockey circle has a 31, 14, 5 and 5 in it. And the rugby circle has that 31, 17, 5 and 3. Eleven, 16, 6 down, carry 1, 3, 4, 5, 6. 66 people like football. 10, 15, 3, 4, 5. 55 people liked hockey. 8, 6 down, carry 1, 3, 4, 5. And 56 people liked rugby. I can see that they all had that 31, so that didn't really need to be added. But I can also see that football here has the highest total. So out of all of the different sports, which sport was enjoyed by the most people? Football. In a class of 24 students, 12 students play the piano, 13 students play the guitar, 4 students don't play an instrument. So I have 2 different instruments. So I need 2 different circles. 12 students play the piano, that would be the entire piano circle. So I can't put a 12 in there because that would have included the people who also can play the guitar. 13 students can play the guitar, so that means that this circle here comes to a total of 13. But I can't put a 13 in there because I don't know how many go in that bit, how many go in that bit, so I don't know how many or how to break that 13 down into 2 numbers. So this question is slightly different because it's giving me information, but it's not giving me information I can use straight away. 4 students play neither instrument. That's easy. I can put a 4 out there. If I think about the fact that I had 24 students at the beginning, and then I've got the 4 students that I've just put outside, I actually know that the circles between them only have 20 students. So all 3 sections, this one, and this one, actually add up to just 20. But if I look at the 12 and the 13, the 12 and the 13 come to 25. So if there's only 20 students in the picture, but the 2 circles come to a total of 25, this tells me that 5 of the students have been counted twice. So this tells me that 5 of the students are in both groups. So 5 of the students are in the overlap. 5 students can play the piano and the guitar. 7 students can just play the piano. 5 students can play the piano and guitar. 8 students can just play the guitar. Those 2 circles in total now come to 20. With the 4 outside makes 24 students altogether. This circle here comes to a total of 12, just like I needed. This circle here comes to a total of 13, just like I needed. Part B, work out the probability that the student only plays the guitar. Well, of all the people in the diagram, these 8 are the ones that only play the guitar. So that would be 8 out of the 24 people in the class. Question 9. In a company there are 110 workers. 90 like tea, 41 like coffee, 25 like both tea and coffee. But we've got to work out which ones don't like either. So I'm going to draw my own Venn diagram this time. I need 2 circles, one for tea, one for coffee. And as I was told about the 25 people who like tea and coffee, I'm going to put that in the centre first. They liked tea and coffee. 90 people like tea, but those 25 have already gone in the picture. So 90, take out the 25 I've put in the middle section, leaves me 65 to put over here. So tea comes to a total of 90. 41 people liked coffee, but like I said, I've already counted those 25. So there are 16 people to put over here. There are 110 workers altogether. And I've seen 106 of them in the circles. So there are 4 people outside the circle, and they are the people who don't like tea or coffee. Question 10, last one. Just because these are in percentages, Venn diagrams work in the same way. So a group of friends have been surveyed. 38% have been from Canada, 80% have been to France, 11% have not been to either. Okay, so 2 countries. And in my circles, I'm going to have in here Canada. 38% have been to Canada. 80% have been to France. 11% have been to neither Canada nor France. There's my 11% who've not been to Canada or France. Again, if you have a look here, the 38 and the 80% comes to more than 100% of the people. And I actually know, because of the 11% that are already outside, that the total for these two should only be 89%, because the 11% is already on the outside. So 38% and the 80%, which comes to 118, is because some people are being counted twice in that middle section. So I need to work out how many people are in that middle section being counted twice. And that would be 29%. 29% have been to Canada and France. And I've got to make sure that I work that out separately so that then I can see how many people have just been to Canada. Well, it's 38, so that's another 9%. Canada's circle comes to a total of 38, but it's broken down into the 2 groups. And how many people have been to France? That's got to come to 80. So with that 29, I need another 51% of people. So that this circle does come to a total of 80, but it's not 80% in one place. Find the percentage of the group that have been to Canada and France. Already done that. It's the overlap, so it's the 29. Okay, there's going to be quite a few videos added to this Revise With Me section. They're going to have specific topics as a focus. So when you're going through topics in class, if your maths teacher tells you that you need to revise a specific topic from a mock exam or from a homework, look in this section to see if there's a video that can help. If there isn't, just ask your maths teacher and we'll put one in.